Hello students, in previous videos we learned the different 6 properties of determinants. So there are total 6 properties. So with the help of that properties we are going to solve the examples of the type show that or prove that. Let us see. Using the properties of determinants and without expanding, prove that determinant of minus a square ab ac ba minus b square bc ca cb minus c square, this is equals to 4a square b square and c square. Okay, just look this determinant. So here we have determinant that is equals to minus a square, or no need to write this, minus a square ab then ac ba minus b square bc ca cb and minus c square. Okay, you observe this. Here in the first row a is common, in the second row b is common, and in the third row c is common. So I am taking a, b and c common from r1, r2, r3. So taking a, b, c common from r1, r2 and r3 respectively. See what happens. This is equals to, you will get here, take a as common from first row, so a, so you will get here minus a, here you will get b, here c, then take b common from second row, so it will be a, then minus b, then c, take c common from third row, so you will get a, then b and minus c. Okay, now this is equals to, see here again in column number 1 a is common, in column number 2 b is common, and in column number 3 c is common. So again I can take a b c common from c1 c2 c3, taking a, b and c common from c1, c2 and c3 respectively. So what happens, I will get here a square, b square and c square, and we will have a determinant that is minus 1, this is 1 and this is 1. Then take b from c2, so this is 1, minus 1, 1, then this is 1, 1, minus 1. Okay, now I can use here row operations also. Okay, so that I will get zeros here. So use, you see here minus 1 plus 1, it becomes 0. Okay, so I am using r1, write r1 as r1 plus r2. Here minus 1 plus 1 becomes 0, 1 and minus 1 becomes 0. So that is equals to, try to bring maximum number of zeros so that it will be helpful to expand the determinant. So a square, b square, c square, the determinant minus 1 plus 1, that is 0, this is 0 and this is 2. Okay, then 1 as it is, minus 1 1 1 1 minus 1. Okay, so that is equals to, now expand a square, b square, c square in bracket. So 0 into this, it will be 0, then minus 0 into, it will also be 0, then plus 2 into this 1 and this is plus 1. this minus 1, but minus of minus 1, that is plus 1. So it is a square b square c square in bracket 0 minus 0, 0 minus 0, this is 2, 2 into 2, that is 4, so plus 4, so 4 into this, it is 4 a square b square and c square, that is right hand side. So in this way we can prove these examples. Similarly, I can take another example. Question number 2. Show that 1 a square, 1 b square and 1 c square, this is equals to a minus b minus c, then c minus a. Okay, try to prove it that the value of this determinant is a minus b into b minus c into c minus a. Okay, so as I want here a minus b, so I am getting from this, if I subtract r1 from r2, then it becomes a minus b. I am to get this factor b minus c, so you take the operation r2 minus r3. So operating here we have a determinant that is equals to 1 a square, 1 b square, 1 c square. Okay, so operating right, r1 as r1 minus r2 and r2 as r2 minus r3. Okay, so we will get this is our delta, this determinant equals to, I will get 1 minus 1 0, this is a minus b, this is a square minus b square, r1 minus r2. Subtract corresponding elements of r1 and r2. Then here 1 minus 1 0, then b minus c, then b square minus c square, b square minus c square. Write third row as it is 1 c square. Okay, now this is equals to 0 a minus b, take the factors of a square minus b square, that is a minus b into a plus b. Here also 0 b minus c, then b minus c into b plus c, this is 1 c and c square. Now this is equals to, taking a minus b, here a minus b, here also a minus b, taking a minus b as common from r1, taking common a minus b from r1 and b minus c from r2. So we get here 0, this is 1 and this is a plus b. I am taking a minus b as common. Here you will get 0, this is 1 and this is b plus c. Okay, then next is as it is 1 c square, right? Okay, then equals to, expanding with the help of elements of first column. Here in the first column I am getting here 2 0, so I can expand this determinant along c1. Okay, so this is a minus b into b minus c. Okay, into, so 0 into this product minus this product, so 0 into it becomes 0, plus this 0 into again this number into this number minus this number into this number, again 0 plus this 1 into 1 into 1 into, leave this row and this column. So 1 into b plus c, that is b plus c minus this minus of a plus b, it becomes minus a minus b. Okay, so that is a minus b, b minus c. Okay, in bracket this is b plus c minus a minus b. So here plus b minus b will get cancelled. This is c minus a. So that is a minus b into b minus c into c minus a. That is right hand side. Okay, so in this way we can prove this value of this determinant equal to a minus b into b minus c to c minus a. Okay, let's take another example. Next example. Show that question 1 and 1, a, b and c, a cube, b cube and c cube, this is equals to a minus b into b minus c into c minus a in bracket a plus b plus c. Okay, now to prove the value of this determinant is a minus b into b minus c to c minus a to a plus b plus c. So solution. So we have this determinant equals to 1 1 1 a b c, a cube, b cube and c cube. Okay, so I am operating here c1, right? C1, this c1 minus c2, it becomes a minus b. I want here factor a minus b, so you subtract c1 minus c2. Again I want a factor b minus c, I will get here b minus c. So applying c1 as c1 minus c2. Okay, and write c2 as c2 minus c3. Okay, so I get here this is equals to 0, 1 minus 1 0, a minus b here, and here a cube minus b cube, a cube minus b cube. The second column will be 1 minus 1 0, b minus c, this is b cube minus c cube. Then write third column as it is 1 c cube. Okay, now taking a minus b and common from the c1 and b minus c from c2, taking common from c1 and c2. Okay, so delta equals to take a minus b as common and from c1 and b minus c common from c2. So we'll get here 0, so it is 1, taking a minus b as common. So here a cube minus b cube, so I can write this as we know that a cube minus b cube, the factors are a minus b into a square plus ab plus b square, right? So I will, taking a minus b as common, so I will get here a square plus ab plus b square. Then here second column 0, taking b minus c as common, so 1, and here b cube minus c cube means you will get b minus c as taken as common, because b cube minus c cube, this will be equal to b minus c into b square plus bc plus c square. So taking b minus c as common from b cube minus c cube, so you will get b square plus bc plus c square. Then third column is 1, this is c and c cube. Okay, now you see here I am getting 2 zeros in the first row, so now it is easy to expand. So this is equals to a minus b into b minus c. Now in bracket 0 into, it will be 0, this is 0, I am expanding along R1, I can write here expanding along R1. Okay, then this 1 into, okay, this 1 into this product, 1 into this, b square plus bc plus c square, 1 into this, minus 1 into this, minus 1 into a square plus ab plus b square, right? So this is equals to a minus b, b minus c in bracket b square, this is plus bc plus c square, then minus a square minus ab and minus b square. Okay, so this is equals to a minus b, b minus c, then in bracket here b square and minus b square gets cancelled, so this is I'm taking bc and ab, here bc, this minus ab, then plus c square, this c square, then minus a square. Okay, so that is equals to a minus b into b minus c in bracket, taking b as common from this, taking b as common, so I am getting b into bracket c minus a plus, taking I can write this okay, c square minus a square, so this is equals to a minus b, b minus c in bracket, this is b into c minus a, plus you take the factors of c square minus a square, that is c minus a into c plus a. Okay, so that is equals to a minus b, b minus c in bracket, here in the first term c minus a is common, here also c minus a is common, so c minus a in bracket, I am leaving here with b, and here c plus a plus c plus a, so that is a minus b, then the b minus c, and these two factors, so that is into c minus a into a plus b plus c, a plus b plus c, that is right hand side. So in this way we can prove these examples. Okay student, thank you.